Okay, hi guys. My name is Tkachenko. I work on the data platform engineering team here at Stich. And today I'll be talking about how to write tools for data scientists that don't suck. So we'll get into it. All right. So how many of you guys are data scientists? All right, full house. Okay. Let's say that you started working at your new job, and you're like, great, I want to expose some data in a dashboard or something like that. And what I mean by dashboard is something like real-time data, graphs, or some other visualization that is important for the business, has a lot of value. So you want to build that. And so that's you over there. You're super enthusiastic. You're full of life. You're like, let's do this. Okay, but you don't have any tools at your disposal, right? So let's see what it looks like when you don't have tools. All right. Okay, I guess a lot of you guys are actually familiar with this workflow. But it looks ugly, okay? So here we have in the green boxes, that's data science happening, okay? That's what you like. All this other crap over here, you just do because you have to, right? They tend to be infrastructure pieces, like let's say you want to get the data out, right? But first, I have to write some infrastructure code to get the data out. Okay, now you do that. Okay, you're tired already. You're like, all right, let's get going, right? Then you're like, wait, I got to keep the data somewhere, right? So let's say you keep the data on S3. And then you're like, oh, great, now I got to put delimiters in there. I got to put metadata, make sure it's correctly configured. Okay, so let's say like 2 weeks later, you're done with that. Then you're like, okay, now can I build my stuff, right? Okay, now you got to build the tools to read the data out of where you decided to keep it. And then, okay, you spend a bunch of time on that. And you're like, all right. Then you're like, okay, I got to set up an ETL. You got to do that because you have tools now that you created. Okay, now you're like, great, can I do my stuff now? Okay, so now you get to the dashboard part. You do a bunch of data science. That's in that green box right there. You notice it's all the way in the last column. Then you're like, okay, now deploy it. Whoa. Okay, but how? I don't know, like we use AWS or something. Just put it on an instance. Make sure it's fault tolerant, auto-scaling, load balancing, you get it. And you're just like, oh my God. This is so complicated. Okay, that's you. All right, you're just like so tired. Life has been sucked out of you. You're so cranky. You're like, I just want to die in a puddle right now. Okay, and then you have to do that whole thing all over again, every time. And then also, anybody else on your team that does something like this will have to build their own stuff. Sucks. All right. This is an oversimplification, but what it can look like is you have some tool to extract the data, right? You do your data science stuff here. You're really good at that. You do that there. And then you push a button to deploy. You're like, yeah, this is awesome. Look at you over there. All right. So before I go into talking about how to write great tools for data scientists, I just want to take a step back before we all get super excited and just mention that on a first iteration, if you're a data platform engineer, don't worry about any of that stuff. Just give them some tools. Just throw it at them, just something rudimentary, something simple, something just, calm their woes. I mean, it's painful to be a data scientist without any tools. But I did want to mention that do not build tools for problems that do not exist. That might be self-explanatory, but a lot of us engineers are like, oh, wouldn't it be wonderful if we did this or we did that? That would be helpful. But that's not helpful if nobody's actually needing that tool. So just some few quick pointers. All right, now we get into the good stuff. So what does it take to build a great tool? So the first part is you abstract out the complexity. Okay, nobody needs to know how complex all this stuff underneath is. Like, the more you can abstract out of there, the better. Like, people don't need to know. Just let them do their job, let them use the tool, and then kind of magically happens for them. So, and if your tool actually requires a lot of internal knowledge, that's a sign that your tool kind of sucks. So you have to keep abstracting and kind of iterate on that until you've taken out all of the really complicated parts and your user doesn't see them. All right, second part is to automate. So you got to automate the process. And so this part, like, don't build a bunch of tools where like your data scientists are like pushing this button and then doing this and then pushing this button and then pushing this button and so on and so forth. If you can automate that thing, that's much better. And they will love you for it because you'll save them time. They can eat popcorn, they can do other data science, and everybody's happy. And also, automating further abstracts out the complexity. So just get it all out. Nobody wants to see any of that. All right. So the last part, the most important part. You want to build a tool that enables data scientists to self-serve. Don't like put yourself in the middle of their process. Don't be a total roadblock for them. So you need to build your tool so that your user, which is the data scientists, are able to self-serve even if things go wrong. So let's say you have some crazy stack trace, if you can make that friendlier for them so that they can kind of understand what's going on and maybe fix it, maybe they did something wrong and they don't know, do it, because it's going to save everybody trouble and it puts you out of the process. And you want to put you out of the process because it's just not an efficient system if you have to email platform every time something happens. Okay, so I'm going to talk about a couple of tools that we have here at Stitch Fix that we built. And so the first one is FLOTILLA, and it removes configuration and installation pain. And that is the worst kind of pain. We all know. All right, so I'm going to go into the background. Why did we need this tool, right? So data scientists, you guys love your IPython notebooks. Yeah, and so we had a lot of kind of need for having, like a Jupyter notebook server, something like that. But we needed it to be multi-user. So we're like, okay, so the first solution was to stand up a Jupyter Hub server on a huge EC2 instance, and I mean huge, huge. Now you gotta go in there, you gotta install the libraries, you gotta configure it all yourself. So it was kind of painful. It went down a lot. It was not very scalable. One host, single point of failure. Chris is nodding. He set it up. So I know it's good that he set it up because we had no other tools, and yeah. So that's the first iteration. So that this might be okay for a few people. But Stitch Fix has 70 data scientists on our team, and we're still growing. So we are huge. That's us right there. Okay, yeah, that's all of us. So what are the problems, right? You have one host, right? So single point of failure. Anything happens, anybody does something weird, okay? The machine goes down, everybody's work stops, it's horrible. You gotta spin it back up. It has a huge EBS volume, has fragile data storage, so I'm getting to that point there. EBS storage, I mean, it's okay, but you don't want to really have to deal with that. You want to make it more distributed and scalable. So again, not scalable as the team grows. Okay, our solution was FLOTILLA. And so this diagram, I wanted to kind of, get you guys into the complexity of it all because it was not a simple tool, really. It's a lot of moving parts. And so FLOTILLA is basically a version of Jupyter Hub that is distributed across many machines, and then the notebook server is running inside Docker containers. And so you have a personal network home directory backed by NFS. You have personal Jupyter, including Python, PySpark, Scala, Spark, blah, 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 RStudio, everything you might want, right? And it also has every library that you might want configured, like installed, everything's ready to go. I mean, that's amazing. And it has customizable memory. So that's why those circles are different colors, see? So those are the Docker containers. So I wanted to explain a little bit about how it works. That up there, this right here, is the ASG, auto-scaling group. So that's how we kind of scale up and down based on need. Those squares, the 3 squares, those are EC2 instances. And then the orange round circles are the Docker containers that are inside them. And we use Amazon's ECS service to manage that cluster. And then we have this really friendly web UI that talks to ECS and is backed by a load balancer. It's nice and steady and scaling and awesome. Okay, so that's what it looks like. So you go in here, you click that new container button, and it gives you this little pop-up that says, give me a name. I called it poop. And I'm notorious for that stuff. My manager gets mad at me. And then you give it the memory. So I chose just 4 gigs, right? And then you click a button, and then this appears, and then you just click on there, and then you have your notebook. And it's kind of amazing. So it has all of the platform tools pre-installed, as well as any other libraries that you might need. So pretty awesome. You look like that. All right. So moving on to the second case study, which is Book of Magic. What Book of Magic does is it simplifies and removes complexity of launching visualization tools. That's the deploy part that everybody hates. All right. So again, I wanted to go through the background of how did we decide that we need this tool, right? So many data scientists started writing dashboards for their business partners. And it's mostly because they were getting all these one-off requests like, hey, can you look this up? Can you tell me this? And blah, blah, blah. And so our data scientists were like, let me give you something to self-serve. So they decided to write some dashboards. But online stuff is hard. Real-time data needs more infrastructure. Code needs to be packaged and deployed. How do you do that? Deployment needs to be resilient to failures. It seems like a lot of stuff to think about. So we had some few brave ones that just went into AWS land, bare bones, and just launched some stuff. But it was clear that a tool was needed. All right, so the solution was Book of Magic. And look at that flow chart, so nice. Data science happens here, push to package code, push to bake, push to deploy. They're literally just Jenkins jobs, and you push buttons to make them go. So we decided, when you're going to automate something, you kind of have to decide what's going to be your paved road, because you can't automate everything for everyone, because different languages have kind of different kinks. So we decided that our road is paved with Python, because a lot of our data scientists who are writing dashboards were using Python. So the tool will package their code into an RPM, and then bake an AMI. An AMI is an Amazon machine image with a push of a button. So kind of background to this, we use the immutable server pattern when we deploy. We just decided that the pros overweighed the cons for us, which is reliability. And then you just deploy to AWS with a push of a button. And the great thing is that the best practices are built into the process, right? So engineers build this tool, right? And so you as a data scientist don't need that domain knowledge, right? Which, you shouldn't really, it's not required. But this is underneath the hood, right? So you have your RPM spec file, you have your code repo, right? This is a Jenkins job. And you click a button to build your RPM. We use Nexus as our RPM repo. Also something you guys don't need to know, and the data scientists a little bit abstracted from them. Then you push a button to bake your AMI, and then you push a button to deploy. And in the deployment, what it does is it spins up an auto-scaling group with the number of instances that you tell it to. The default is 2, so that it's fault tolerant. We also have Chaos Monkey running, if any of you guys know what that is, but it just kills instances randomly. And we do that so that everybody follows the best practices. So auto-scaling group, instances inside is backed by a load balancer, and then traffic comes in through there. So a lot of stuff happening. So the second part that's interesting is what happened after we gave the data scientists this deploy tool. So deployment was so easy now that data scientists started writing web services to integrate with our core engineering apps, which was amazing. And so some of the examples include, like, we push style recommendations straight into our styling application. That's a web service that data scientists had a huge part in. Smart fix assignments, inventory allocation, warehouse allocation, like from which warehouse should we ship the fix. So that's pretty cool. So you go from like, I don't know what to do with this dashboard, like it's not going online, like how do I deploy it, to like legit web services. That's pretty cool. So some takeaways. Make your data scientists' lives easier. They will love you for it. They will become efficient and very productive. And they might surprise you with writing all these web services. So the 3 points again: your tool has to abstract out the complexity, has to automate the process, and it has to enable data scientists to self-serve. Ah, yes. Do you guys have any questions? Yes?
Why is the face so sad?
I don't know. Just doesn't want to leave. I likes you guys.
Great.
Thanks.
Are there any plans to open source like the JUPYTER hub deployer?
So far as I know, there are no plans, but we are not opposed to it. So if you guys like it and want it, we sure will. Yeah.
How do you share the data across all these notebooks?
How do you share the data across notebooks? Well, you have your own home directory backed by NFS, right? And so you have your own stuff and you're kind of separated out. So I don't think that we share data across notebooks, but you can see somebody else's notebook, which is what seems to be more important. So yeah. Okay.